Hey, sorry guys, again the network got disconnected. Today, again I had to rejoin. Okay, start sharing my screen.
తింటారండి Hi Shiva, good morning.
Hello Ramesh. Yeah. So let me keep you all mute. Getting some background noise. Yeah. Sorry for late starting today. So I woke up a bit late today, and again after that, the net got disconnected. Okay. So let's get freshly started with the Hive topics today. Yeah. And so I hope everybody completed their big assignments and they have revised the big concepts. So what is Hive? So it's one another ETL tool similar to your Hive. So it can be termed as many things. Okay, so not just one ETL tool. So Pig can be termed as an ETL tool. Okay, and it has similar to SQL syntax. Similar to SQL, but not syntax is not similar. And it's a abstraction layer on top of MapReduce. Okay. So these are the 3 points about if I need to tell. Okay. And coming to Hive, I can say so many points about this. It is a Hadoop's data warehouse. This is a data flow language. And it uses its own Big Latin. Now coming to Hive, so it uses SQL dialect, which is Hive QL, Hive query language. Almost same like your MySQL queries, MySQL query syntaxes, all the commands. And so it is a data warehouse, SQL dialect, It contains the email stack. So one good example, if I give you one better requirement, and if I give you the answer both in Pick and Hive, then you will prefer Hive is a better one than Pick. Okay. So let's say I have an employee's data with ID and name and department and yeah, let me take only this many. Okay, so I'm loading this into table. So load this path into table in Pick. First I need to define this as int and this as char array, department equal to again char array. So once I load it, I want to group the people by department and get the counts of them, okay, and sort them by the descending order, and I need the top 10 departments who is having more number of employees. So my question is top 10 departments with max number of employees. If this is my requirement, so first I will load this. Okay, in Pick, if I have to do this, so what can I do? So group B equal to group A by department. Okay, now you will get all the groups. If you want to get the count of them, so C equal to group for each B, generate group comma count of $1. Okay, now you get the counts. So we need to sort here. So D equal to order C by as EMP or as count, any name you can give. Order C by count in descending order. And finally, you need only the top 10 results. So limit D 10. Now dump E. So these are your Pick statements. Unfortunately, you can't change, you can't merge them into all into one statement or two. Okay, so you can't merge this for each statement with this group by and this group by into load statement and this order by into this for each. So you can't combine this order and limit statement. So you still have to write 6 lines of Pick statements, whereas if it is your SQL, I can write this into select count of ID select count of ID, department from employee table, group by department, order by either you can give this count of ID, descending order, and limit 10. Okay, so more or less similar to this. So you can complete your query in one single SQL statement, even it is having inner queries, subqueries. So from programmer's point perspective, so as a typical developer, I feel better, even more better with Hive. So you will agree to this, right? So this is one improvement, but anyway, this is not the reason why we switch to there, to Hive, why we prefer Hive over Pig. Hive can do almost all the operations that Pig can do. Whatever it could be data types, it could be your operators, it could be relational operators, it could be your loading your different file formats, it could be connecting to your DBMS, or it could be you're writing your user-defined functions. Whatever you did in Pig, you can do in Hive. And on top of it, from a typical developer's perspective, your code got even more reduced. But these are the minor reasons. So the major one is Pig is a data flow language. You can't persist the schema there. So once the employees table is stored, is loaded into Pig engine, these three columns, and I got the top 10 departments with highest number of count. So after dump E, if I come out of grunt shell, again I need to load this table and do the sequence of steps. Okay. So at least this loading statement, this is more of like a creation of a table, because you are telling the path and you are telling the schema every time. So in Hive, instead of loading or instead of that load statements every time, we can create the tables by specifying the path and schema in the beginning of usage itself. So once the table is created, so it will be present until you explicitly drop it. So this is a typical data warehousing system. So that means it will have databases and tables. So it could be star schema or snowflake schema, any type. Okay, so data warehouse means. So in this data warehouse, the major components, it will have databases and tables. Now, coming to other terminologies on data warehouse, this acts like a OLAP, online analytical processing. Okay. Analytical processing means, so taking a historical data, let's say it could be 3 months of data or 6 months of data, or 1 year of data or 5 years of data. So take some minimum amount of historical data and do some analysis and find out the derivations. So read your 6 months of log files and identify what are all the device models that are generating more error messages, and what is the similar problem, what is the problem in all those device data models. That is one identification that we can do. And in case if we are talking about retail domain, so what is the product that is having outstanding sales in the last 6 months in a particular state or a particular country. So that way, this Hive is used as a data warehouse to store the historical data. Okay, and coming to here in data warehouse terminologies, in database terminologies, we have two things. One is data warehouse. Second one is a database. Okay.
Shiva, I got disconnected. Is everybody can see your screen?
Yeah, this is Lakshman. I can see it.
Okay. Maybe
Okay.
so it's some. I got.
Okay. Yeah, I think you can connect back and then you will be able to might be. Okay. So to discuss about the data warehouse concepts, we can segregate them two ways. So data warehouse, this is purely related to the data warehousing concept, not something new in Hadoop or Hive. Okay. So data warehousing means it stores the history of data. And its main purpose is for on historical data on a huge amount of data. If you want to take a decision which product is having outstanding sales, you can conclude that at least if you can see the results of last 3 months, minimum of 3 months, then you can't sell it, you can tell it by 1 day transactions or 2 days transactions, right? That might not be that accurate. So that to take analytical decisions or conclusions, so we'll consider at least 3 months of data or 6 months of data in minimum. Okay, so its main purpose is for OLAP, and yeah, they will have the same like databases, tables, and all that stuff. Okay, so these are the purposes of data warehouse. Coming to database, so the main intention is to OLTP. Yep, response latency, high latency. I will explain you what is high latency. So OLTP, online transactional processing, means transactions means you're insert a record into a table and delete, update, or not, are supported. Okay. Here, OLTP is not supported. Let me explain you more about this. And we'll store only the latest data in this, maybe last 1 month at max of last 1 month or so. Okay, and low latency compared to it. So here in OLAP historical data, so if I have a table with 10 million records, 10 million records across over a period of 6 months. Okay. So since it has a 6 months of data, or 10 months, let me take 10 months of data. Since you have 10 months of data, it has 10 millions of records. So inside that 10 million records, suppose somewhere in the 5th month or something, or even the latest month. So if you want to change a record, if you want to update a record, so then within that 10 million records table, the insertion of a new record or deletion of a record or update of a record, in terms of our DBMS data warehouses, even though they are supported, but you will maintain some databases as data warehouse, and you keep on dumping your data up to some years and months and years. So on that data, even though your Oracle or Teradata or these things support your transactions on them, but those databases are not intended for performing the transactions. They are only for generating, do some analysis and generate reports. Okay, so these are for reports and these are for instant transactions or lookups. Okay, or searches. So if I have 10 millions of records over a period of 10 months, this is huge data. Touching one record to update or delete it will be relatively very slow. Okay, so let's assume I have only one month of data, or even just last 1 week or 1 month of data. Then I have only 1 million record table. So inside this 1 million record table, changing a record will be relatively fast. Okay, so I hope everybody agrees that. That's the reason in databases, in RDBMSs, some database that you create, so you don't explicitly specify any keyword to create such kind of schemas, but you will maintain only the latest snapshot of data in that, and you will be doing the transactions inside that. And if you want to store your historical data, so you'll create another schema, and there you will keep dumping of your data. Keep dumping your data for days, months, and years. So in database, your requirement is to provide the latest snapshot to the end user, show him on screens or through SQL queries, and instantly, if he finds any mistake in any record, if you want to change the employee name, there was a typo in the name, he can directly update that record using some update statements, or if he finds that so and so employee got deleted, so if you want to delete that employee record, he can do that, just that one employee record. Whereas in OLAP, these transactions are not supported. So whatever you do, there will be bulk operations at table level. So that means if you want to add a 10 records, you can't simply add one after the other into the existing table. So you should write those 10 records into your files by some mechanism, or you write a new file, you create a new file with including the existing 10 million records and the new 10 records, and then reload this complete 10 million 10 records into the table. So reloading of data, if you want to have any changes inside that table. And if you want to delete some records, deleting only a selected records is not possible. So you can drop the table, complete table. Then you will lose all the records and reload, then later reload only the records, put the excluded records into a file and reload that file into the table. So any operation that you do here, they will be at table level. In database, any operation that you will do, it will be at record level.
Shiva?
Yes, Ramesh.
Question. You gave example of having 10 million records already in the table, and we're trying to add another 1,000 records.
10
or let's say another record.
10, yeah,
10 records.
Okay.
So all 10 million will be already stored in the HDFS in the file format, right?
No, I'm not talking about HDFS as of now.
Okay.
I'm talking about pure data warehouse and database concepts.
Okay.
Okay. Yep. Now tell me.
And one question. High latency means the response time would be.
I'm going to explain that. I mean, that's why. I was talking in the sequence, like, yeah.
All right. I'm sorry.
Yeah. So if I give a pass break or something, then please stop me. Otherwise, so I'm already in a sequence to explain these things. Okay. So here, since on a huge data set, adding one record or deleting one record, it's relatively very slow, and that's one reason once we treat one schema as a data warehouse, we don't do the transactions on that. And once we treat a schema as a database, we'll store only a latest snapshot of data, and we'll try to keep the data as minimum as possible. The reason is, if you have few records and as an end user, if you find a policy record or an employee record with incorrect data, and the end business user saw that record in the screens, and if you want to update some policy number or policy name or employee name or something, if he does that update, if he gets response after 1 hour, so will he be satisfied in real time? Obviously not. So that's the purpose of databases. They support the transactions, and if he updates a record, or if he queries for one employee record, he should not wait for minutes and hours for that record. Okay, so just for one record. So to support that record level operations so quickly and so instantly, they maintain the less amount of data in their schemas. So giving the results in quick time, in fast time, is called the low latency. Latency is nothing but the response time. So how much turnaround time? So once you submit the query, so within how many microseconds or how many milliseconds, how many seconds you are getting the response. Latency is nothing but your response time. Since you have less amount of data in database, you will get, obviously, the results will be faster. Okay, and this purpose of database is used to support the end user transactions. And this purpose of data warehouse is, so we'll not expose this as a to the end user directly to perform transactions, but we'll take 6 months of data or 1 year of data, and then we'll prepare a report. We'll prepare a report, something like, hey boss, this is for last 1 year. So these are the products that are performing very well. And these are the products that are not performing well. And these are the stores that are performing well. Okay, from these stores, you have lots and lots of sales. And during these seasons, during these periods or weeks, you have high sales. So in order to come to these many conclusions, we'll get accurate results only when you have enough amount of data to take those conclusions. Just by looking at a 1 week of data, telling this product is having high sales, invest more on this, that might not be a good decision. You need to observe the track record of at least for last 6 months, minimum of 6 months, and or even 1 year, 2 years, as huge data as you can take. That will result you that much of accurate values. Okay. So I hope you understood the differences between data warehouse, the purpose of data warehouse. You can discriminate the differences of purposes of data warehouse and database. So in this database, you will maintain the latest data, and once the data reached a 1 month older, let's say every day you are receiving some records. Okay, on again 31st day, so you will have last 31 days of data, and on 1st of the next month, and 1st of next month, it will store that the 1st of previous month data into your data warehouse. It will ship that, and once you enter into 10th of the next month, let's say July 10th, then the first 10 days of your June data will be automatically shipped into data warehouse. So once it becomes 30 days older, that data will be moved into your data warehouse. So once it becomes beyond the 30 days older, it will become your historical data. This is the typical scenario that happens in your data warehouse and database concepts, even in traditional RDBMSs. So here, to categorize or to segregate my Hive into these two types, so it falls on data warehouse part. And we have one more tool called HBase that we'll discuss next after completion of Hive and Impala sessions. That falls under your database. So here it is Hive. In terms of Hadoop terminology, it is HBase. Okay.
Shiva, data warehouse and ETL are both the same.
Data warehouse and ETL.
Yeah.
ETL means it's a tool. It's just a tool. It need not be like your Informatica is one of the ETL tool. But can it store data? It should connect to some data warehouse and extract the data, and it can transform it and it can load it back to another database.
Okay.
So here, why I use the ETL, I know why you are asking this question. So as I was telling that Hive can do all the operations that Pig can do, and Pig is like another ETL tool.
Yeah.
Here, Hive QL, you can take it as a mechanism for ETL. Like, so you can have your databases or schemas and tables created in Hive. So whenever I use schema, don't get confused. Schema is nothing but a database. So schema or database both refer to the same meaning. So when I create a schema in Hive, you can apply your SQL queries. Transform your 10 columns table into by applying some aggregations and produce some aggregated result table. So that is one kind of ETL transaction, or you can call that is one type of transformation. Right? That's the reason why we can call as Hive. Hive is a data warehouse, and inside that you can do ETL operations.
Okay, Shiva.
Now, whatever the limitations that you have for data warehouse, they all holds good for your Hive. So when I say whatever the benefits, whatever limitations that data warehouse having, they all will holds good to your Hive. Okay. So now Hive is suitable. Coming to the positive side of it, it can store historical data. It can store years and years of data. Coming to its negative sides of it, it cannot support, or if I complete the positiveness of it, history of data, and good for OLAP, online analytical processing, and the valuable outcomes out of your Hive is reports for end users. So coming to the negative sides of it, you can't perform transactions, record level transactions, I should call this as, okay. So record level transactions not supported, and your low latency cannot be achieved. Since you will perform your queries on huge amount of data, you should not expect your results to come within milliseconds or seconds, sometimes, at least. If your data is small, then you may expect your results to come faster, in seconds, obviously not in milliseconds. Okay, so these are the features when I compare with traditional data warehouse. Now, if I compare with Pig, as I was telling you, it can do all the ETL transformations. Can perform all the ETL transformations like your Pig. And one more similarity with this is even Hive runs the MR jobs in the backend. Same like Pig, when you submitted your Pig scripts, it was converting them into MapReduce jobs, and those jobs getting executed. Once the jobs are completed, then you are getting the results, right? And here, Pig was just a client software in terms of architecture or in terms of infrastructure point of view. So Pig is just a client-side tool, right? As I was clarifying your question once again in Anand. Okay. Here, Hive can also be just one another client-side tool. I'm saying it can also be. It can. Okay. So if I want, I can run only on client tool itself. But we'll have, let's say, there are many users, if they want to access that through the shell, accessing your Hive tables similar to your Pig grunt shell. So here we will have Hive shell similar to grunt shell. That means similarity even in the shells means, so in Hive shell you can run your Hive commands. In Pig shell you can run your Pig commands, and you can run your HDFS commands also here, right? We have seen that fs space -ls, and given the path it was listing down, and Linux shell script commands as well. Then these two, in similarities, even these two can be achieved here. So, especially when you are accessing through the Hive shell, yes, you can just leave your Hive set up only in the edge node. Okay. But if you want this access via your JDBC connections, similar to any of your typical RDBMSs, like if you have data in Oracle, data in Postgres, data in MySQL, data in Teradata or Netezza. So we will, through our programming, if we want to access that through your Java programs, or through your C or C++ programs, then we need the JDBC or ODBC drivers. Java database connectivity drivers or open database connectivity drivers. If it is Java programming language, we use JDBC or Java based kind of programming. Or C, C++, we use ODBC drivers. So typical to any RDBMS, I mean similar to any typical RDBMS, even Hive does support the connectivity to Hive in 3 ways. Like, so Hive connectivity options are, one is through shell, Hive shell, where you run your commands directly in the shell itself. And second one is through the JDBC programs. So might be Java clients, I can say. Okay. And third one is web UI, web user interface. From a web browser, exposing your databases and tables to there and running your queries in the browser itself. So this part we'll see in our Hue sessions. Until then, let's keep it aside. Let's park this aside. Okay. So first we'll be testing inside in Hive shell also, running them in interactive fashion means running your commands on the shell itself and seeing the results there, one after the other queries. And batch mode. Batch mode of execution means put 10 or 20 of your Hive commands into your file, the same way we have seen in pig. So write all the pig commands into your file, and we used pig -f space followed by your script file. And similarly, here also write your 10 lines of your pig Hive commands into one file and use Hive -f followed by the file name. Okay. So in Hive shell, again, 2 types of execution. One is interactive fashion, and where you run query by query and see them, and you will wait for submission of another query until the completion of current. In batch mode, you write all your queries into one file and you submit that file.
Shiva?
So, Satish, yeah, just give me a few more minutes. See, I know you will get lots of questions. Thing is, there are various things that you need to compare Hive with. You need to compare Hive with your typical RDBMS data warehouses, or compare RDBMS. These are the questions also you'll get in real time in interviews. So whether you understood the differences between these Hive and RDBMS, and compare with NoSQL database, compare Hive with NoSQL DB HBase, and compare Hive with your pig, and compare Hive with HDFS. I'm going bit advanced in telling all these differences. Okay, so in one shot, you will not get it, but this is something advanced. If you know the scope of this with respect to these counterparts, then you will better understand the role of it. Okay. I got a question. If we load in Hive shell and close shell, do we need to load file again next time or not? We don't need to. It's not loading a file. As I was telling you, it's creation of tables. We have schemas and tables in Hive. Okay, so we'll see that part. So I'm just giving you still the overview and comparisons with, so whatever the tools that you are already aware of. Okay, so compare with so here Hive, I hope you are you got these features of data warehouse, and these are for database, and you understood some of these features for Hive, right? So coming to comparing Hive with RDBMS, so almost all your RDBMSs, they can serve as database. Okay, and again, I don't need to explicitly tell all these differences. Hive cannot be used as database. It's a data warehouse only. Okay, your RDBMS can be used both as database and data warehouse. So one Oracle server can be used as database, and another Oracle server can be maintained only to store the historical data as a data warehouse. And one more thing, schema on read and schema on write. So this is one another major difference. Like when you are writing any table when you are inserting any record into an RDBMS table, your RDBMS, your Oracle checks. Let's say you have a record with ID, comma, name, comma, age. Okay. And if you are passing ID as 123 and name as Ramesh and age as 100. So it will throw an exception, or it will stop you saying that. So schema mismatch. So this age column expects an integer value, but you are giving a string value. Whereas your Hive, while inserting that record, it will not throw any error message. It will simply accept that. Here in Oracle, it will not at all accept that record. But in Hive, it accepts that record, but while reading that, that age column will display that as a null. So when you select that employee record, you will get employee ID as 123, name as Ramesh, and age as null. So that means at the time of reading of your record, then it validates its schema. Means whether this value is matching with its data type, its column data type or not. Whereas in RDBMS, that validation happens at the time of writing itself. So that's why if you are writing a 10 million records into your Oracle, it takes a very long time in Oracle, relatively very long time in Oracle, because for each and every record, it has to validate the schema and then write into the table. So writes are, because of this, writes are relatively slow, but reads are faster. Okay. On the other hand, writes are faster. Let me write here. Writes are faster, but reads are little slower. Okay. So these are the two major differences when I compare with Hive and RDBMS. So since this is a data warehouse and this is a database, so all other differences that I noted down in the above holds good here again. Now coming to the HBase and Hive, yes, in simple terms, if I have to tell, this is a SQL and this is NoSQL. This is another difference. And this is data warehouse and this is database. Okay. Now, coming to pick Hive exactly supports SQL syntax. Pig is not SQL, not direct SQL syntax. Okay, similar to that, not direct SQL syntax. And once a table is created in Hive, tables are persisted here. Persisted in Hive. Whereas once a file is loaded and you perform some transformations, if you come out of your big shell, then you're again you need to reload if you want to perform any other operations next. Okay, so not persistent here. The state is not persistent here. Okay, I can say that. And this is also it can also do ETL transformations, and even this can do the ETL transformations. It can store historical data. Historical data can be stored here. No storage of data, right? So all the data will be present in HDFS. On need basis, you will load that into your big temporary workspace. No storage of data, only temporary workspace. Temporary workspace which stores until the end of session. Once you come out of your big session, it's lost. That is with this. Okay. And here, Hive with HDFS. So Hive, if you know, HDFS does not support updates to files. And Hive uses HDFS as the backend file system. So if you load any data into Hive table, that data should either come from, so in real scenarios, it comes from HDFS file system, or you can directly load from local file system. But that gets copied onto your HDFS files only. So what I am trying to say in this statement is that your Hive uses your HDFS as the storage layer. It stores all its data in HDFS files only, but when you view it through Hive Mirror, they will look like as a tables to you. In the backend, it is simply a file only. It is still a file only in the backend, and you can still access. You can still perform your file operations on that HDFS file. But if you if you see it through Hive Mirror, if you take that Hive as a mirror, then it will be shown to you as a table. As a table and as a database. Okay. So, I mean, these are a bit advanced for now, at least for now. So these are the basic things I want to highlight. So this one supports, this one submits the map MR jobs. Even this one submits the MR jobs. Okay. And Hive's backend storage is HDFS, and Pig's backend storage is also HDFS. But this relation between the table name and the HDFS location is persistent in Hive, which is not persistent in Pig. Once you come out of Pig session, that will be lost, that relation. Okay, so it is just an overview and to explain you the pros and cons or the strengths and limitations of your Hive. So at least now you can tell what it can do for us and what it cannot do. So now you start with your questions, Ramesh, Satish, and whoever is having the questions. I take care. I mean, I will give you a pass of 5 minutes. Only on overview.
Siva, can I go ahead?
Yes, Anand. Yep.
Okay. Thank you. Couple of things.
Mm-hmm.
So Hive is a database also. Is that what I'm getting? Sort of.
No. In every comparison, I am telling you, Hive is not a database; it's a data warehouse.
No, that's what I meant to say. Data warehouse, meaning that, see, because the important question here is with RDBMS. RDBMS should be compared with the Hadoop FS, not with the Hive. Hive is a client tool. So that is where my confusion is.
Okay.
Right?
So why I am comparing with RDBMS is that, so you are taking because you are treating this RDBMS as only in terms of storage perspective. In terms of querying perspective, here you will use SQL syntax, right?
Correct.
Same SQL syntax I will use here. Same in the sense 95% assume. So even if it is 95% matched, I call it as 100% matched here. Okay. So same SQL. Okay. And here you will have data segregated into your, let me not call that as, you are aware of what is meant by schema, right? A database.
Correct. Yeah, absolutely. Database. Right.
So in this data model, schema or database, again, I mean, whoever are not from data warehousing background technologies, they confuse with database and data warehouse terms, and they confuse with this schema and the purpose of here I say schema on read. This here's my schema refers to the column names and their column data types in this line. Even that also we call it as a schema or layout, or and even the database is also called as a schema.
Yeah, the table space and everything, right? That's what you meant by that.
Yeah, especially I'm worried about Murli and all these guys. I mean, they are from data warehousing database background, so they might get confused with these keywords for a couple of days or so. Okay, so you need to focus on in which context I'm using this. So even in RDBMS, I have schema, database, and tables, views, okay, sometimes indexes, and so on, right? Here,
yep.
At least I have all of them. May not be all of them I might be using, but most of them. At least indexes are also supported in Hive, but we use till here schema, database, tables, and views. We'll find all.
So in essence, Shiva, Hive uses HDFS as a surrogate.
HDFS has storage in the backend.
Storage in the backend. So, but it has its own native code to store the tables and to retrieve the data of the tables. That's what the difference is.
To make it more clear, Hive will, and this is again another contradictory statement again is my view. Hive will not store any data in its own space. First of all, it will not at all have any space for dedicated, something that is unique to Hive or something that is accessible only by Hive. Any data that you store in Hive, it's nothing but a HDFS directory or a HDFS file.
So does the Hive write the table definitions readable only to Hive?
Yep, the table definitions and their column names and their data types. So they all will be maintained in Hive Meta Store.
Okay.
So typically, this is an RDBMS.
Yeah, I got it.
Most of the times, this will be stored in RDBMS, and preferred ones are MySQL or Postgre. And again, so this might confuse others for some time. So that's why I didn't talk about this. Okay, so even if others didn't get this point for now, let me put this aside for some time. Let's discuss that, and I will directly show that. Okay.
Shiva, one question. I think even we can access the Metastore, right? Hive Metastore.
Again, yeah. Let's discuss this.
Yeah, that's fine.
Okay. So because there are few other folks which are new to these terms, so I don't want to make them confused. Okay. So is Java client used in real time or just Hive Shell and Web UI used? You may not like the answer, Satish, but the fact is, yes, in real time you will find the Java clients also being used. Based on this.
So Siva, what is the solution for slowness of, because I'm kind of worried now because Hive is reading the data records.
There is a solution. Right?
What was that? Sorry, I didn't get
problem, and people will not sit silent, right? I mean, they go and find the solutions. Now,
right. Okay.
So for that question, the answer is simply Impala.
Impala. Okay. Okay. I was hoping that. Perfect. Okay.
Okay. So that's why. So now, do you feel that so Hive is better than your pig? When you are learning pig, you decided that pig is better than MapReduce, and then you start doing your coding in pig only. Now, so do you agree that Hive is more preferable than pig? Because if you are not from data warehouse background, obviously pig syntax is new for both Java developers and as well as SQL developers. But Hive syntax, it might be familiar for both Java and as well as the SQL developers. SQL developers anyway, they will be expert. And Java developers, they might be doing at least bare minimum SQL queries through their Java programs. They feel comfortable with the SQL syntax, and they feel comfortable with these, at least the terms like databases, tables, and views. And they feel comfortable with the JDBC clients. Okay, and coming to the performance wise, Pig and Hive, there is not much different. There is not, I can say, I mean, not in ideal terms, practical terms, like I can say, they both are almost the same because they both submit the MapReduce jobs only in the backend. Obviously, they are going to take, say, as good as your MapReduce job execution time. And one more advantage with Hive is that once a table is created, that table definition is persistent in Hive, whereas it's not in Pig. It's just temporary. That definition itself is also a temporary in Pig. So that is one, I mean, these are some reasons why these days Pig got almost ruled out, I can say. Maybe down the line, because in some places, people ask you if you put your resume as 2 years, 3 years of experience, then they will question you whether you have experience on Pig or not. If keeping only you are joining as a fresh Hadoop developer and you need to focus only on the upcoming tools, you can 100% omit learning Pig. It's my guarantee that you hardly find it using in any client unless until they were using it from last 3-4 years and they have some maintenance tasks on that. Okay, so why are you telling this statement after re-practicing all those commands and all? You don't ask me this question. Okay. Because since I know you all guys will put a, I mean, decent experience in your resumes on Hadoop, then they expect that at least they might ask you a couple of questions around that. And even that is needed for your Cloudera certification, they will cover that Pig syllabus as well. And in case if you find any clients who are older, like 3 years, 4 years older into Hadoop, they might have written some Pig scripts, and in case if they want to maintain that code as it is, then that is the right place where you can use your Pig skills. Okay. So what about MapReduce? Yes, this MapReduce, the limitations of your programming language versus your SQL tools will always remain same. Like, as I was telling you, the limitations of your Pig when compared with your MapReduce, you cannot do the for loops in Pig statements, right? And the same way in SQLs also, you can't do loopings in SQLs. You can't write your loops in SQL. You can't express your for loops based on a criteria and perform different operations within that for loop. You can't express that in your SQL syntax. Obviously, in that scenarios, we should go with some programming language. So as of now, with the tools that you have learned so far, you have an option of coding it in MapReduce. But since this is a performance-wise, this is a batch-oriented, and it takes relatively longer time. So you have to go for Spark, which is the next buzzword, at least for couple of years. Couple of years is guaranteed. Okay. So in open source community, of course, every tool becomes outdated if it is 3-4 years old. Okay. I have a question. So this may be out of context, but why Pentaho? Pentaho is like an ETL tool, right? Like your uh, Informatica or Talent. Yes, that's Talent is also another kind of ETL tool. It's mostly used by testers. So they connect to one source database and run their queries, and they produce the target database and just validate that. No idea on ETL much. Yes, I know, because you are from Java background, and even Murli is also from Java background, and there are few folks from Java background. You guys might not have much knowledge on the generic ETL skills, but there are few guys, Anand and few others, are from ETL background. They understand. From here onwards, they will pick up bit faster, and Java guys, you need to spend more hours to understand all these terms and things. You need to do some homework as well. Okay, I'm trying to explain as much as here itself, but if you don't understand some of the basic terms, so I would recommend you to do the basic homework. Like, so understand what is data warehouse, what is database, what is table, what is database, what is views, what is called schema, what is star schema, what is snowflake schema. So those all things I might not be able to cover in Hive sessions, because that's purely data warehouse sessions. Then it will become like these guys will get bored. The same way, like if I tell the differences between string and int, float, and double in Java. Okay. Or if I spend hours and hours in explaining the difference between class, object, and method. Okay. So Talent is an open source. It's a competitor to Pentaho. Yes, Pentaho is another. Talent and Pentaho both are open source ETL tools. Okay. So these are ETL tools, and you come across some reporting tools also, which I will be taking those names, like reporting tools like MicroStrategy, ClickView or ClickSense, and some visualization tools like Splunk, Tableau, Zoom Data. So all these things. For the namesake, I will be explaining what is what, just 1 or 2 lines. Okay. Again, this Hadoop is like an ocean. Like, you will mix each and every tool into this. You have that scope. I mean, it's not like you intend to do that. So most of the enterprises, they leverage that feature of integration of all these tools. You can your Hadoop can be integrated with your RDBMS. It can be integrated with your Amazon Cloud. It can be integrated with your ETL tools. Yes, you have integrity with your Informatica also. You have integrity with Pentaho. You have integrity with Talent. You have integration with reporting tools. You have integration with visualization tools. Okay, so that's more of like too much of scope for now, at least for you guys. Keeping developers' perspective in mind. So just first learn the Hadoop tools one by one. And anyway, so integration with database RDBMSs, you'll see in Scoop, and integration with your reporting tools or visualization tools like Tableau, I will try to cover in Hive, just at least the theory part, and showcase the steps to do that, and I will leave that up to you for your exploration. But in real time, as a typical developer, you'll be working only on these tools, and only the senior architects or those things, they will provide that integration to them. That is also one-time setup. So once that is set up, actual Tableau developers or MicroStrategy developers, all those BI guys, we call them as BI guys, business intelligence guys. So BI reporting tools, those guys will take care of. Feels pretty good today. Okay, for me, which topics I should concentrate? 6 years experience. No, good to go with only Hive. Yeah, that is fine, Swaroop, but don't limit yourself because you're fresher. I mean, almost like fresher. So try to grab as much as you can. Hive and bit of MapReduce because you have Java knowledge. So for you, Swaroop, I mean, concentrate both on Hive, Impala, and HBase and MapReduce. The bare minimum stuff. MapReduce only in exceptional cases, which you can't achieve through Hive or Impala or HBase, then go for the MapReduce. Okay. Yep.
Shiva, question.
Yes, Ramesh. Yeah.
We said Hive internally uses HDFS as a storage, right?
Mm-hmm.
So and HDFS has the immutable nature, right?
Correct. You can't update the records. You can't delete.
Right. So yeah. So when you're trying to add a record to the existing Hive table, then how it will take case internally?
Did I tell that Hive supports transactions?
No.
You are advanced. I know that. You know that.
Oh, no. At least if you add an additional record, will.
But I didn't tell you that, right?
Okay.
Okay. I mean, I know you're curious, Ramesh. The thing is, see, you know that there is an insert statement in Hive that got introduced in Hive 0.14. Okay. So that might be, yeah, that not might be, that will work. And in order to explain that, so my own statements will get contradicted here for others. You know the context that.
Oh, yeah.
You're getting my point, right? Till now, I'm telling that Hive will not support transactions, neither insert nor delete nor update. I mean, for today, that statement as active. I will do more small modifications to that tomorrow or day after tomorrow. And again, even if I do the modifications, so whatever you're talking about inserts, so that's a waste feature. You will not use that at all in real time.
So every time you load and you delete the existing file and create a new one, is it?
Yeah.
Okay.
So my today's statement will holds good till the end of the Hive session. So Hive will not. Hive is, at least I can rephrase the statement. Hive is not intended for transactions. In the recent releases, they supported insert, but it's not useful feature. The reasons I will show you there itself.
Shiva, you told Hive is used for
Hive?
historical data. For some years of data we can store. Hive will use for historical data, right? For years of data.
Yep.
So all this data will store in HDFS. It's a wasting of the storage, right?
Wasting storage? Why?
Because you're storing 3 years of data. A lot of data you're storing, right?
Oh man, data is precious. See, every enterprise runs on data only. How can you say data is waste? See, so there is some phenomena that happens, that might happen only once in a year, twice in a year. Then even those phenomena are being captured in data analysis, in machine learning, just by storing the data of, I mean, for longer period of years. If you know any data scientist, asks them, if you want to do any machine learning, how much of data you want. They always ask for Can you give it for 2 years? Can you make it for 3 years? If you can make it 5 years, even more better. I can give you better accurate results.
Okay.
Okay. See, simple basic funda. Let's say if you take, so product sales, okay, or product units being sold. So today being Sunday or today being Tuesday, I sold only 10 units because this is a weekday. On Saturday, I sold 100. So what if you take average? You will get around 55. Is that accurate? Average sales per day? Obviously not. If you take a week of data, so then you may get 15 here, and you may get 20 here, you may get again 10 here, and you may get 15, something like that. And over a Friday and over Saturday and Sunday, you got 90 and 100. So then it might come around, let me just guess, okay? So it might come around 40 or something. Is this accurate? Is this closer to the, can you guarantee that it is the exact value match?
No.
We cannot, right? And if you take an year of data or a month of data, if you do average of month of data, it might come around 30. If you do an average of over a period of 12 months, so then it might come around 20 or so, which is closer to your actual values.
Yeah.
Okay, so the more historical data you take, the more accurate decisions you will get.
Okay. Okay, Shiva.
It's not waste. Don't call data ever waste. At least in front of these data scientists or machine learning guys.
Okay.
Okay, so they love the data like anything. They take, if you give just 6 months of data, they in front first statement, I may not give you the accurate results. They expect at least minimum 2 years of data.
Siva, what about time series and slowly changing dimensions and that kind of stuff?
Time series DB, this Hive is not intended for that, Anand. Like, we can think of HBase in some scenarios for time series kind of stuff, but the better one is, I can say, maybe using Spark streaming on the fly. Once the data comes in, process and plot, and you can integrate with your graphics or something in Spark and plot the graphs on time basis. Okay, so that is one option, or you can keep storing your streaming results.
Okay, and then
Cassandra
what is
time series? Yeah, Cassandra and HBase are being used in some places for time series transactions. Okay, for others, I mean, don't worry, guys. I mean, if you don't know what is meant by time series transactions or time series database, okay, there's something out of scope for now, at least.
Siva, where does HBase fall into here? I'm not clear on HBase. Is that a database or it's a?
Yeah, if you observe the Hive features, this has lots of. See, in typical enterprises, you need both data warehouse and database, right? In any enterprise.
Right.
So I told you that Hive can solve only the purpose of data warehouse. Then who is going to fulfill my database requirements? It's the HBase.
So HBase is like more of a traditional database system.
It's not a traditional database, but you can make, or you can use it something similar to that. Okay, for now, I mean, just focus on the left side part. We'll discuss the HBase things during the HBase sessions.
Okay.
So here the limitations of your Hive is that it cannot support transactions. There should be someone who does that job as well for me. And instead of waiting, suppose if you want to check only one employee record, to check that one record instead of waiting for a minute or so. So it would be better if you can get that in some milliseconds or seconds at least. So even to satisfy the instant responses and OLAP transactions, so and to maintain only the latest copies of the data, so we use HBase for that. So there are again, so you'll get lots of questions. You need to transition your thoughts towards this in the next sessions. We'll do there.
You answered about time series, but what about SCDs slowly changing?
What is it? H series.
Slowly changing dimensions, or because historical here that makes a significance because you are talking about history.
Yep.
So how does that work?
Slowly changing dimensions.
Remember if you recall that if I want to know what addresses I was living in the past, right?
Oh, okay, okay.
Similar to that.
So that's again like trending. Okay. Yeah, good question. I think.
So Siva, like the best example is
even that. See, even that can be stored in HBase itself, not in Hive. Yep. The reason is we support a feature called versions there in HBase. So if you can definitely do that in HBase.
Okay.
Trending values of particular dimension or something.
HBase and Hive goes hand in hand, right? They go together, right?
Yeah, they can go that way also. They can run in independently. Hive can run independently, and HBase can run independently, or you can mix both of them.
Okay.
As well. You can access your HBase tables in Hive, and you can access Hive tables in HBase also. We'll see that also.
Good.
So from here onwards, it's more of like a databases and tables, all this stuff. And you'll feel you don't need to write lengthy lines of code, just commands. Only in case of, I will just show you one Hive client, Java client. So that is in case if you need in real time, you can do that. Okay. So let's get, I am left with 10 more minutes. Let's get started with our slides. So it was just an overview to tell you the scope of what Hive can do and what it can't do. Any questions so far? Okay. So yeah, so I have 10 more minutes.
Can you hear me?
Yes, Lakshman. Yeah. Hello. Yes, Lakshman, I can hear you. Tell me.
Yeah, I wanted to ask you, in the Hive, is it possible to just share the outline of what you would be covering in Hive?
Oh, in Hive, what we will be covering in Hive tool?
Yeah, in the curriculum, what are you going to discuss?
Okay.
Just outline.
Okay. Yeah, that is a good question, but I think I shared that course contents with you guys. If not, let me pull that out. Hadoop training course. So what all we will be covering in Hive? So this is our course contents. Like, so even though I specified here 45 to 50 hours, it will extend beyond 60 hours. Okay, don't worry about the hours. And so in Hive, so Hive architecture, we'll see types of meta stores. So Hive data types, Hive query language, partitioning and bucketing features. So JDBC clients, how to write the UDFs, how or different types of service. Hive on page, this I may not be able to show you. This works only on Hortonworks, not on Cloudera. Even if it's just a matter of setting one property, but we'll do that later. And integration with Tableau, and also I will show the integration with HBase. Integration with HBase, I will show the examples running, but Tableau, I lost the license. So license is expired on my machines, so I can't reinstall. But I will go through the document that I prepared with detailed screenshots. You can do it on your own.
Okay. Yeah, would you be covering? Sure. I mean, thanks for sharing this. Would you be covering the the design approach for Hive? When you define the Hive metastore or Hive schema.
Hive metastore, that anyway, I will cover that. Okay. So design point of view, that's a, I mean, to be frank, that's a broader scope. Like, I mean, few folks may get it. In which scenarios you should go for what?
Okay.
Like, and others might not get if I talk purely on design. But I will try to give you. Okay.
Just outline. Yeah. Okay.
Okay.
Thanks.
So you can use, I mean, generally we'll see some places the flat schema, and some places we see the star schema, and some places we can find the snowflakes model, data model types.
Okay. Sure. Okay. Thanks.
Okay.
Yeah.
Yeah. Any other questions? Okay. Yeah. So yeah, let me start with the slides. The first slide. So in this slide, the new thing that you should know is Hive is initially developed at Facebook and contributed to ASF. ASF means Apache Software Foundation, open source community. And it became a top level project in Apache in 2010. From there onwards, people started using this. Okay. So what does Hive provides? So it acts like an ETL tool, mechanism to project a structure on a variety of data formats. Means if you have a CSV file, or if you have a tab separated file, if you have a JSON file, if you have some other sequence file, or if you have an ORC file, those are file format. These are data base, I can say, like text files, tab separated files, and JSON files, all. And all of them, you can project a structure. You can define what are the columns, what are the data types. And you can view that JSON file as a table. So access to file stored either directly in HDFS or other data storage systems such as HBase. We'll see both of them. Okay. So query execution through MapReduce jobs and SQL-like language called HiveQL that facilitates querying and managing large data sets residing on Hadoop. Okay. I hope no questions in this slide as well. And RDBMS versus Hive. RDBMS can be used both as database and data warehouse. Your Oracle, one example. Hive is a purely data warehouse, and it supports RDBMS supports schema on write. That's why you can't insert an invalid record into table. Whereas Hive supports schema on read, you can insert invalid record into Hive, but at the time of reading, you will get those mismatched columns as null values. And this runs on a notion of read and write many times. And this is Hive is write once. Once the table is loaded, you can read it many times, but you can't update or delete. That's why write once and read many times. So record level insertions, updates, and deletes is possible. It's not possible. And yes, coming to the scalability of your typical MySQL, Postgres, or Oracle, they scale up to sizes of tens of terabytes, whereas Hive scales up to hundreds of petabytes also. Because the underlying storage is HDFS. Our DBMS is suited for the dynamic data analysis, and where your data keeps on changing every day. So to support those changes, you need RDBMS. Whereas Hive is more suited for static data. Once the data is loaded, that should be static. Then that time it is a good fit for Hive. And this is for OLAP and this is for OLTP. Okay, so I hope everyone is clear with that. Now, as I was telling you, in Hive architecture, so we can interact with Hive in 3 modes. Yeah, right? So one is through Hive shell, and second one is through JDBC Java clients, and third one is through Web UI. Web UI is nothing but accessing that through the browser. Same, you have seen the HDFS file system through the browser, right? Localhost 50070 port number, you have seen that, right? In your Kickstart VM. That way. So that is Web GUI. So JDBC is through Java programs. And CLI is, which is nothing but command line interface, which is Hive shell. So these are the 3 ways that you can interact with your Hive. Now, if you submit your queries through either CLI or any of these 3 modes, then similar to your pig engine, in pig architecture, this JDBC was not there, but Web GUI is present in pig also, but we didn't talk about that. But anyway, in our Hue sessions, we'll see all these Web GUIs together. Okay, in one session itself, we'll see all these Web GUIs. So Siva, these all 3 ways you will explain to us. These are all 3 ways you will explain to us. Yes, Murli. These all 3 ways I will explain to you. Okay, yep. Not just the CLI and not just the JDBC. I will show the Web GUI also during our Hue sessions. Okay. Next, this CLI. So no matter from whichever you send your commands, through whichever way you send your commands, same as in your pig architecture, if you remember, this is like your grunt shell and this is like your pig engine. So here we call it as a Hive driver. Okay. So inside that driver, same as in your pig subcomponents, pig engine subcomponent, we have compiler, optimizer, and executor. Even in pig architecture, we have seen those 3 or 4: compiler, optimizer, and executor. So this compiler compiles your SQL commands and checks for the syntax errors. If there are no syntax errors, it compiles it properly. And then optimizer finds the best optimized way to execute them. And then the executor is the one which converts them into MapReduce tasks, and they will get submitted into your Yarn resource manager. And from there onwards, it's just one another typical MapReduce job. Okay, so this meta store is just to maintain the metadata of your tables. So if you have a table, if I want to know how many tables are there in Hive and what are their table names and what is the column, what are the columns in each table, only the metadata, the list of databases and list of tables and list of column names and their data types in each table, and where is its actual data located, that path. So here metadata means list of databases, how many databases that you have in Hive, list of tables, how many tables you have and what are they, and list of columns, column names and data types, and each table information. So metadata about table is nothing but column names and data types and tables physical data location. Physical data means where is that actual data located in which HDFS file. Physical HDFS file location. So table name, column names, data types, and database name and HDFS file location. This bare minimum data is called as metadata of that table. But actual 10 million records will be stored in HDFS. But the DB name is just one string, right? DB name. And table name is another string. And column names may be few strings. And HDFS file location another string. So bare minimum, these few strings, like not beyond 4 KB or 5 KB of data. So this metadata will be stored in a meta store. Typically this meta store will be your RDBMS. Why we are storing the, or you can think Hive equal to as Hive equal to data stored in HDFS, actual data. Okay, actual data in HDFS. And let me take MySQL just example. This is metadata. So actual data will be stored in HDFS and metadata will be stored in MySQL. So now, so can you say that Hive is storing something? No, it's not storing anything by itself. It's relying on both HDFS and RDBMS. HDFS for storing the actual data and RDBMS for metadata. Okay. So in Hive, we'll only have the Hive driver, which takes your Hive queries, responsible for compiling them, optimizing them, and converting that into MapReduce jobs, and they will read on your HDFS data and During this compilation time and during the optimization time, it accesses the metadata. So MySQL kind like name node storing file info in HDFS. Exactly. MySQL is just storing the file infos and table names and column names, similar to your name node, serving that purpose. Meta store, metadata. Okay. So let me stop after this slide. So once I submit the queries to driver, so it submits the resource manager, and if it has to read any HDFS file, then it will send a request to name node as well and reads the data on the data nodes plus star stack. Okay. So again, similarly, if you get a request from WebGUI, the same flow. And even if it is from JDBC or ODBC, we'll have in between. We need a Hive server to be running for JDBC and ODBC clients, because you don't know when your Java program will be submitted to your driver. So for that, to serve all your Hive requests, to send your Hive requests to Hive driver, so we submit JDBC programs or requests through Hive server. For CLI mode or for WebGUI, you don't need the Hive server. You can directly log in into your shell and run your commands. That shell itself will interact with the driver in the backend, and this WebGUI also does the same.
Shiva, is the Hive server and the Thrift server are the same?
What is it?
Hive server and the Thrift server.
Same.
Okay.
You should not call it as separate. You may call it as Hive Thrift server.
Okay, Shiva.
Okay, you should call it as Hive Thrift server because it uses the thrift serialization in the backend. That is one kind of serialization mechanism, similar to your Avro or something, or kind of one of the serialization mechanism to send your binary data over the network. So since it uses the thrift server, we call it as Hive Thrift server. Anyway, these days, Hive Thrift server is outdated. We are no longer using Hive Thrift server because of its some limitations. We'll directly learn the Hive server 2 itself. Okay, Hive server 2, which is advanced than your thrift server. Let's not worry about that low level details of that much, but let's start learning just the Hive server 2. Okay. So UI means user interface. Driver, we understood the purpose of driver. Inside that compiler and the meta store component that stores all the metadata of that. And the actual execution engine, which is responsible for optimizing and converting that into MapReduce tasks or jobs and running them. Okay, so this one, this is also more or less similar to that only. Yeah, it would be better if I can complete it right away. Otherwise, yeah, let me freshly start with the Hive commands tomorrow. So I will explain this architecture once again. Do you have 5 minutes or you want?
Can we do this tomorrow?
No problem. Yep. No issues. So I thought I'd freshly start with Hive shell tomorrow and start showing the commands, create tables and all that stuff. No issues. We'll start. We'll discuss this slide once again so that you will get a second time recap of the same thing.
Perfect.
Yeah.
Thank you.
Okay. Any more questions? Okay. If not, then let's meet tomorrow, same time. Thank you, guys. Thank you very much. Bye-bye.